Alright, let's be honest with each other. It's a little concerning that you've managed to keep a human body functioning for this many years without having a basic clue about its most famous internal rebellion. Today, I'll be explaining what cancer does inside the body to you like you're 5 years old. And by the end of this, you'll finally understand the biological drama that has baffled you for decades, and you can go back to worrying about more immediate problems, like what to watch on streaming tonight. Your body is a massive, super organized city made of trillions of tiny little building blocks called cells. You have more cells in your body than there are stars in our galaxy, which is a pretty fun fact that you can use to sound smart while completely avoiding the actual topic of conversation. Anyway, each of these cells is like a tiny, dedicated worker. You have skin cells whose only job is to be your personal human shield. You have stomach cells that are professional acid bathers breaking down the questionable burrito that you had for lunch. You've got lung cells that do nothing but trade good air for bad air all day long, and every single cell has a specific job, and they are very, very good at it. This whole city of cells runs on a very strict set of rules. I mean, your body has more regulations than a grumpy neighborhood association, and for an extremely good reason. These rules keep everything in order. Cells are told when to grow, when to work, when to make a copy of themselves, and most importantly, when their shift is over and it's time to retire. This isn't a sad thing though. I mean, it's a necessary part of keeping the city clean and efficient. Old, worn-out cells gracefully bow out, and new, fresh cells take their place. It's a perfect, beautiful cycle of life and work. So, where do these all-important rules come from? Inside every single one of your trillions of cells, there's an instruction manual. And this manual is called DNA. And think of it as the ultimate employee handbook, and it is incredibly detailed. It tells a cell, you're a liver cell. Your job is to clean up messes, and you're allowed to make one copy of yourself, but only if your neighbor gets damaged and you need to fill in. And after you've worked for a specific amount of time, you must begin the self-destruct sequence. I mean, it's very clear. The instructions are the law. Now, what happens if there's a typo in the instruction manual? Well, your body is constantly making new cells, which means it's constantly photocopying this massive instruction manual. And just like the sad office copier that always leaves a smudge, sometimes mistakes do happen. A tiny error can creep into the DNA, and this little error is called a mutation. Now, most of the time, these typos are no big deal. I mean, the body has amazing little proofreaders, which are other parts of the cell that run around fixing typos as they happen. They're the microscopic grammar police of your biology, and even if a typo slips through, it might be in a part of the manual that doesn't really matter. It might change the instructions from your favorite color is blue to your favorite color is blue. I mean, the meaning is the same and the cell works just fine, but every now and then, a typo does happen in a really, really important sentence. Imagine the typo changes a critical rule. Let's say it lands on the sentence that says, you must stop making copies of yourself, and the typo changes it to, you must never, ever stop making copies of yourself. Or it hits the sentence that says, your shift is over, time to retire, and it changes it to, you get to live forever and you never have to clock out. Now this is how a cancer cell is born. It is, at its heart, a rule breaker. It's a cell with a broken instruction manual, and it's forgotten how to listen. Now, while all the other cells are diligently doing their jobs and following the rules, this one cell goes rogue. It starts dividing, and it makes a copy of itself. However, that new cell now also has the same typo in its instruction manual, so it also starts dividing. And then those two make two more, and those four make 8, and on and on and on it goes. A runaway train of cellular disobedience. This growing pile of rule-breaking cells is what we call a tumor. It's a disorganized clump of cells that don't belong, and they don't do the job they were originally supposed to do. A cancerous lung cell, for example, doesn't help you breathe, it just sits there, making more useless cancerous lung cells. They're like a bunch of clowns who showed up to a construction site. I mean, they aren't building anything, they're just piling up on top of each other, getting in the way of the actual workers and eating all the donuts from the break room. Now, not all tumors are created equal. There are two main types, and it's like comparing a houseplant that's gotten a bit too big for its pot to a horde of angry raccoons that has invaded your attic. Now first, we have what's called a benign tumor. And the word benign is just a fancy word of saying not so bad or kinda lazy. The cells in a benign tumor are rule breakers, yes, but they're contained. They form a clump, and that clump grows, but it stays in one place. It's like a neat, tidy little pile of troublemakers. They have the decency to build a little wall around themselves, keeping their chaos to their own little area. A benign tumor can still cause problems. I mean, if it gets big enough, it can press on things, and a big benign tumor in your brain could press on parts that control your vision, causing blurriness. It's like putting a giant sofa in a tiny hallway. The sofa itself isn't evil, but it's blocking all the doors and you can't get to the bathroom. Doctors often go in, surgically remove the clump, and then the problem is solved. Benign tumors are not cancer. They're just a local disturbance. But then we have the other kind, the angry raccoons, and this is the malignant tumor. This is what we call cancer. Malignant is a fancy word for mean or nasty. The cells in a malignant tumor are not just rule breakers, they're vandals. They don't stay in a neat pile, they have no respect for personal space. They actively invade the neighborhood around them, and they'll grow into healthy tissues around themselves, destroying the good, hardworking cells in their path. Now, they don't build a nice little wall around themselves. No, they're messy, aggressive, and their only goal is to expand their territory. And this is the gang that doesn't just hang out in the corner. It starts breaking windows and tagging the walls of City Hall. But the real defining feature of cancer, the thing that makes it so incredibly dangerous, is its ability to travel. This is what separates the local bullies from the international crime syndicate. This process is called metastasis, and it is without a doubt the scariest part of the whole deal. The cells in a malignant tumor are so chaotic and disorganized that some of them can break off from the main clump. They squeeze their way out of the original tumor and go looking for an escape route, and your body is full of them. It has a super efficient transportation network. I mean, you got blood vessels, which are like the superhighways of your internal city. You've also got something called the lymphatic system, which is like a network of smaller back roads and drainage canals. These renegade cancer cells are clever. They find a way to get into one of these highways, and a little piece of the tumor breaks off, slips into a tiny blood vessel, and gets swept away into circulation. It's like a single angry raccoon stowing away on a cargo truck. That one cell can now travel anywhere in the body that the blood flows. It can take a ride up to the brain, it can float over to the liver, it can end up in the bones or even the lungs. And when it gets to its new destination, it simply hops off the highway, finds a nice cozy new neighborhood, and does the only thing it knows how to do. It starts dividing again. It starts building a brand new tumor, a new franchise of the original gang, in a completely different part of your body. This is what makes cancer so hard to treat. I mean, it's one thing to deal with one gang in one neighborhood, but it's another thing entirely to deal with that same gang starting new chapters all over the city. And here's the really important part to understand. If a cancerous lung cell spreads to the brain, it's not brain cancer. It is metastatic lung cancer. The cells that are now growing in the brain are still lung cancer cells. They just took a road trip. They're lung cell clowns who are now causing a disturbance in the brain cell library. And this is a crucial destination because the treatment that works on lung cells won't necessarily be the same as the ones that work on brain cells. You have to fight the cancer based on what it is, not where it is. So, how does this all actually hurt you? I mean, it's not like the cancer cells have tiny little knives, but they do cause damage in a few very logical and terrible ways. First off, they're resource hogs. To grow and divide at such a crazy speed, these cancer cells need a ton of energy and nutrients. They're incredibly hungry. I mean, they essentially steal food and oxygen from your healthy, hardworking cells. And they even trick your body into growing new blood vessels directly to the tumor, creating a private delivery service just for them. Your good cells start to starve while the bad guy gang has a feast. This is one reason that people with advanced cancer can feel very weak and tired. Second, they cause physical problems through crowding. As a tumor gets bigger, it takes up space. And it's a simple matter of physics. A large tumor in your intestine can block it, making it impossible for food to pass through. A tumor in your lungs takes up the space that your lungs need to fill with air, making you short of breath. They push on nerves, causing pain. They squeeze organs, preventing them from doing their vital jobs. They're the ultimate uninvited house guests who not only eat all your food, but also slowly shoves all your furniture out of the way until you're stuck in a corner. And third, as we discussed, they actively invade and destroy. Malignant cells don't just push healthy tissue aside, they chew right through it. They break down the very structure of your organs, which causes bleeding, organ failure, and a complete breakdown of all the normal orderly city of cells. And finally, they can even mess with your body's chemistry. Some tumors release their own substances and hormones into your bloodstream, and this can throw your whole system out of whack, causing weird symptoms that have nothing to do with where the tumor is located. It's like the gang is not only taking over the neighborhood, but also poisoning the city's water supply just for kicks. And all of this is happening while your body's police force, the immune system, is trying to fight back. Your immune system is designed to find and destroy invaders and rule breakers, and a lot of the time, it does. It probably finds and zaps tiny little would-be cancer cells in your body all the time without you ever knowing. But cancer cells are sneaky. Some learn how to wear disguises, making them look like healthy cells. Some realize signals that tell the immune system to stand down, and sometimes the cancer just grows so fast that it completely overwhelms the police force. So, to wrap this up in a way that a 5-year-old would nod along to, cancer is what happens when some of your body's cells get a broken instruction book. Because their book is broken, they forget the rules and decide to copy themselves forever and ever, making a bad guy gang called a tumor. If the gang is lazy and stays in one spot, it's a problem, but usually a manageable one. But if the gang is mean and the members start using your blood highways to go on road trips and start new gangs in other places, that's when it gets really serious. That is what cancer does inside your body. You see? You get it now. It isn't some strange, unknowable monster. It's just biology going terribly wrong. It's a system of rules, and cancer is what happens when the most important rules get broken. Alright, class dismissed. Now go thank your trillions of cells for behaving themselves today. Mostly.